Hey everybody, could you use some good news? Well, let's start with this. A team led by professors from Mexico and New York has published a study that could change the way we think about so-called junk DNA. While the exact function of junk or non-coding DNA has been a subject for research and debate, the general assumption has been that it must do something, confer some selective advantage, otherwise why would we have so much of it? That assumption is being tested thanks to a study published in the journal Nature by the international team that sequenced the genome of the carnivorous bladderwort plant. The bladderwort's genome consists of only 3% non-coding DNA. The other 97% is all genes. And that's not all. There is evidence that the bladderwort has deleted non-coding DNA from its genome during the course of its evolutionary history. Bacterial genomes have low levels of non-coding DNA, but for larger, more complex multicellular organisms, larger amounts are thought to be the norm. For instance, the human genome consists of 98% non-coding DNA. Only 2% of our genomes actually code for proteins. The genome of the bladderwort plant confirms that while so-called junk DNA may be very common, it is not necessary for highly complex and successful multicellular organisms. It's a really fascinating find. Speaking of the human genome, a new study has identified 4 previously unknown genetic risk factors for testicular cancer. A study at the University of Pennsylvania examined the genomes of 13,000 men and discovered 4 previously unknown genetic variations which they associated with increased risk for testicular cancer, which is relatively rare overall, but is the most frequently diagnosed type of cancer in young men. Knowing what these risk factors are and who has them will enable scientists and physicians to better identify those at risk and to improve efforts at early detection and prevention. And finally, researchers at the Institute of Photonic Sciences in Spain have developed a new quantum mechanical measuring technique that allows them to make observations at the subatomic level without disturbing the objects they're observing. The measurement technique involves pulsing photons through a cloud of atoms and measuring their polarization. The method allowed the research team to observe the spinning of electrons in the cloud of atoms without disturbing the atoms. The first time that's ever been done. The genome of a carnivorous plant improves our understanding of so-called junk DNA. Researchers identify 4 new risk factors for testicular cancer, and scientists successfully take quantum non-demolition measurements for the first time. That's the good news.